Working on electronic equipment has many hazards associated with it that can cause injury and/or death. Please do not work on energized equipment unless you take proper precautions. Working on such equipment is done at your own risk and not at the prompting of information from this or any other YouTube channel. Hello and welcome back to Poor Man's Electronics Bench. In this part, I am going to cover difficulties I created for myself when trying to upgrade all of the original single-turn trim pots to modern multi-turn components. As it turns out, schematics and parts lists do not always reflect the engineering and final configurations of completed devices. Go figure, huh? And in this instance, that is exactly what happened, causing me to take a step back and figure out a practical solution besides just leaving well enough alone. I found that I could not easily source a direct replacement value trim pot in a multi-turn style for that particular value, so I figured I could do some maths and make it work out properly with a value trim pot that matches the schematic and can be adjusted without as much of a fudge factor. If you think you may be interested in this content and info, please stay on channel. Hello and welcome back to Poor Man's Electronics Bench. I don't know how many of you people are familiar with the phrase, never confuse activity with accomplishment, but in this case it's definitely valid, and that's what I found myself running into. In my attempts at trying to update all the trim pots on this LC53 unit, I came to a issue where there was one setting that I could not properly adjust within range, and I was having great difficulty doing it. It was behaving really badly, and I was kind of wondering exactly why that was happening. So it turns out that this guy is the little culprit here. It's on the 100 board, or this particular part on the schematic. Everything on that board is called the 10XX is the part number, and this one would be R1031, or what is called 100 or 75K potentiometer. In particular, the 1031 shows on the schematic as 100K. And I didn't realize it at first until I ran into installing it and then finding out that it had a 25K different value. Didn't think it was going to be a big deal because I just thought it was going to be something that was a inline series resistance calibration. As it turns out, this particular trim pot is in the middle of a feedback loop on IC1004C, which is an op amp. And the funny part is this value and this value, R1030 and R1032, the static resistors on either side of the loop are correct. Now this one, since it's got positive 5 volts, probably didn't change much, but the whole thing of getting the voltage around, through, from, signal, whatever, on this whole network was changed, disturbed, disrupted when I changed this to a larger value. And it turns out that I can no longer keep within any proper calibration range because of that. And as it turns out, it looks like this is part of the calibration for the meter. It's part of it acts like a DVM basically, and there's a section where you go through meter calibration on the instructions. It says the internal meter readout calibration should be checked and adjusted if necessary before calibration of any of the ranges on the Z-Meter. So it says turn it on, If the readout does not show 000 with negative sign appearing occasionally, adjust the rear panel meter. This isn't the rear panel one, so we don't have to worry about it. Now, before this, they tell you that you're going to need a voltage source that is capable of putting out 0.09 and 0.9 volts, which is to be used in the calibration here. And then we're going to get to me not being able to locate the page properly. Here we go. With the output control, the DC supply set to minimum. Connect the positive lead of the ungrounded end to R1082. Connect the negative lead of the grounded to the grounded end of 1082. So we have to go in on the board when it's plugged in live and hook a voltage source. And it says connect the DVM such as a VM37 or DVM38 to the same points, and then adjust the power supply for a reading of 0.9 volts DC across R1082. Then it says adjust R1035 on the Z-Meter for a readout of R1035 is one of its counterparts, probably another pot on the op amp, but another section on the op amp. So we'll take care of that one. And it says reduce the power supply output to 0.09 volts DC is measured on the DVM, and adjust R1031, which is our culprit, for a readout of 0.89 on the display. I was having difficulty doing that, and apparently if you don't have the capability of making this adjustment, it's going to cause problems with a lot of other readouts on the meter. So it says repeat steps 3, 4, and 5 2 or 3 times as the controls will have some interaction. So I was going back and forth ping-ponging and finding out that I really couldn't get things set properly until I kind of looked at things and realized that that particular puppy was part of that feedback loop in that op amp. So I went through some math, I figured out some resistive values, and then the next scene I'm going to go over testing them as a spice model to make sure everything's working okay. And now I'll take you to my new preferred spice modeling site. It's called everycircuit.com. I was using Multisim, which was another freeware site that had a beginner level, like me, choice of things to model circuits from, and they decided to kind of clamp down on things and really won't let you drop in new designs. I can play with the old stuff I have there, but I can't do anything really new without subscribing. And if you subscribe, there's probably some value to it. I think it was like $10 a month, and they do let you access a lot of other stuff, and I'm not really happy with a lot of stuff on LT Spice, so I decided to just stay away from there. And there's some stuff I play with there, but I'm just trying to learn this one and see how it behaves. And it's interesting. It's got some interesting features to it, but it also probably has some limitations as well, unless you upgrade and pay on this, which you can. But anyways, I have built a little circuit of 2 different networks being fed with the same voltage. I'll just go over it. I've got the voltage feed at 2.23 kilovolts, which seems awfully high because it is. But the main reason I'm doing it is just I'm using these LED lamps kind of partially as a ballast and a current indicator for what's going on in the output of the Trimpots. This section is just isolating and showing the network of resistors that were the original values in the unit. So again, this adds up to 75K. Schematic showed 100K. That's what I ordered. And no, I ordered 100. Yeah, schematic showed 100K, so I ordered that. But putting the 100K in there changes a lot of things. So first, I'm going to go over the reworking of values of the resistors and how they behave when I do that for all 3. I did some math and worked out the overall value of the resistors because seeing that is part of a feedback loop from the output back into the op amp, it needs to have a similar value, which putting this resistor in there at a 25K larger value kind of screwed things up, and that's why I was having the problem calibrating everything for that one section. So I ended up working out the math and replaced 185K with 169K 1% resistor. The 75K is the 100K orange trim pot that I put in there, and the 100K that's in the unit now is going to get replaced with a 90.9. I think the math needed to be like a 91. It's 1/10 off. It's a 1% resistor. It's all within tolerance. And right now, if you see, if the trimpots are set at 50, they're both set at 50% value. This is the way I want the circuit to behave with the new trimpot. This is the way the old circuit behaved. I could go in, you see I've got 1.93 volts at 10 milliamps flow. This is 1.93 at 10.2, feeding the LED. And my ground is upside down. I can flip that. It's a fun little software. You can flip things around and go back and start it up again and run it on the transient function. What I'm going to do is I'm going to change the value on the wiper position on both of these. So you click on the little wrench over there, and then you can change your resistance on the resistor and then your wiper position, and you change it with a rotary dial that pops up on the right side of the screen. So right now I'm going to go to 0% or 1%, and if you notice, that gives my LED more current, gives this more voltage and more current than that as well. I'm going to change this one as well to the 1% position. Wiper position is 50%. Going to change it to 1%. And it's 1.96 volts. It's only 1/100th of a volt off. It's not bad. Current 13.112. It's still within range, and this can be bumped over a little and just be adjusted to the same maximum as this one, so it's within, I can take this and adjust it back and get it to that 1.95 value. It's got to go. There we go. Going at 12.9 milliamps, but I can adjust it to it. You can make fine adjustments by clicking the plus and minus over here too, which is nice. Probably needs about 5% or so. So I could go a wider range of adjustment here, which is nice. Shouldn't need to. Maybe it'll take 10%. Or a little more. But you get the idea. This configuration of a resistor network falls within the same parameters as this one. It actually has a little more adjustability, but I shouldn't need to use that. Looks like it's going to be about 15% to match it. Like I said, it's no biggie. It's just that this is a 100K wiper. This is a 75K. It's just that this is going to have the same resistance, same network and the resistance. The same current flow in the resistor network. It's just that you've got more adjustability on the tap for the wiper. And we're going to go to the max. Just to go back to this one, we'll go to the maximum over here. Take that to 99%. And if you look now, I've got 8.58 milliamps on my LED on the tap, and I'll do the same. What I'll do with this one is it looks like I'll try to 85%. That should be pretty close. %. That gives me 8.75, so I can knock it down. I can get the same adjustment range with the 100K, with changing those two resistors. Knock it down a little more. Oh, actually, I need to go the other way. What was I thinking? Yeah, I need to drop the current a little bit. That requires more resistance. There we go, 8.6, 8.58. So you get the idea. It just have to make those changes in order to use the 100K. So we'll go back to changing the resistors, installing the two parts, or showing you where the two parts are, installing the new ones, and then you have to put everything back together and try to go through calibration again. And just to double and triple check things, I was going to check the part numbers on the schematic and double check the locations of the parts and mark them to kind of make sure I'm playing with the right things and I'm making my changes here. Going back to the schematic here, everything's on that analog board, that 100 or 1000 board or whatever you want to call it, so everything is going to be prefaced with a 10 for a part number. So we've got a R1030, which is basically R30 on that board, which was a 185K, and the other one's a R1032, which is a 100K. So we're going to zoom in on the board itself and pointing things out here. You've got an R32 that looks like it's standing up there. That looks like 100K. So I'm going to do is take that guy and I'm just going to mark it with some pink highlight marker here. And then the other one is an R30. And that's the 185K that's laying down on the job. So I'm going to mark that one as well. Then another one I'm going to go for, so I don't know if I was mentioned before, it's going to be the R82. Now, they use that R82, it's right there, it's 100K, they're using that, either side of that resistor as a test point, and if you notice, that thing is just tight to the board, and I tried to do some calibration work on it before, it's hard to get a hold of that resistor. I have a replacement for it, so I'm just going to go in. I'll mark that one. Even though it's not defective, it's gonna. Well, this marker isn't working too good on it, but I've got a resistor for it. It's going to. What I'm gonna do is I'm gonna pull that one out, and I'm gonna put a new resistor in with brand new long leads. Of course, I'm gonna stand it up off the board a little bit to give it a good shot to clip on leads to, instead of having to fight to get that thing. It's it's the figure that maybe somebody at Sencore could have figured that out, but they were probably just. Production line, get it in a hurry, get the parts in, get it out the door. So we're going to go for making those changes off camera. I've got my desoldering station warmed up, so I'm going to make the changes on the resistors and then come back when I'm done, and we're going to see what things look like from there. Okay, I am back. I got the changes made. I'll zoom in on the board and show you the new resistors are also half watters. It's just that there's such a disparity in size. They're half watt, 1% Vachets. And out of respect for myself and others, I always like to make sure that when I install stuff like this on a board, if you don't have color-coded values, put the value so it's legible up on top, and this one you can look around to the side enough to see it. And then for R82, you can see the one now, it's standing well proud of the board to make for easier access. And what I did is I also printed up a little flag label I can put on there. It might be a little overkill, but it'll make things easier for anybody else, including me, to try to get in here and find a puppy. Could have made the label a little smaller, but really doesn't matter. It's just going to kind of indicate, hey, that resistor that you're looking for in this tree hiding out in the forest of parts here is the one that you're looking for a DVM test point. So I think right now that's where I'm going to leave this particular part, because I have to get everybody back together and get it powered back up and then see if my changes are going to be the correct ones to make things work properly. So I hope that you gain some insight from working on one of these things. If you felt the need to change the trimmers, especially that one, and you found out that your adjustments are off, this is the main reason why it's going to be. You will not be able to make these two adjustments for the linearity, or at least the one of them, that R31, since the original was a 75K and that was laid out in the feedback circuit of a op amp. You're making a lot of changes, so you have to make the corresponding changes to make things work. I am going to take some time to go off camera and reassemble this unit and reattempt to calibrate things. I will release a video soon with these exploits, and if all goes well, this will be the final video of working on this unit. If you would be interested in seeing this work, please subscribe to be notified of the next video release, and if you like the info, please click a like for it. Thanks for viewing, and I hope you visit again soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.